Galaxy. Okay, this is a spiral galaxy. This is called the Whirlpool Galaxy. See these stars here? These guys, these are not in that galaxy. These are Milky Way stars that just happen to lie between us and that galaxy, right? So the cool thing is that there's a phenomenon called a supernova, where this galaxy could actually sprout a new one of those, and it would be in that galaxy, where one star can be, gentlemen, where one star can be as bright as an entire galaxy, okay? And so you can see that, and there's people that have gone and they can look at a galaxy and they've memorized all these foreground stars, enough so that if they saw a new one that was in the galaxy, they'd know it, right? And this is something that's actually important to... supernovas, and they had like a reading assignment. Oh, that's cool. Okay, now I promised you guys that I would show you how to identify barred spiral. So here's a really good picture of a barred spiral. And the thing to do is everybody wants to look right here for the barred spiral, right? They're like, okay, there's the bar. Here's the best thing to do. Don't look there. Look more this way. Look down here. Keep going. Right there. See that? That says barred spiral. See, if it was a normal spiral, it wouldn't say barred first. That works every time. Okay. Yeah. Jen's like, I wish I hadn't stayed here to... Okay. This is two galaxies that are colliding with one another. And here's a crazy thing. These stars, we know these stars were just born. Here's how we know they were just born. They only live like 10 million years. Stars that size eat their fuel so fast. Big stars last such a short time that we know that these guys are only 10 million years old. So this collision had to be, this collision likely caused, I just can't stand this. Let's have Danny Anderson, why don't you come up here and sit in front of Laura, and Connor, why don't you go sit in front of Alex? Would you do that, please? Just kind of scoot. Yeah. Let's just move around. Let's just try. And we could, okay. They know that these things were just born, okay, because these things are brand new stars, okay? So we think that this collision caused them to be born. In fact, if you look at galaxies often orbit other galaxies, and when they get close to each other, when the galaxies get close to each other, they will actually light up a little bit. When they pass near each other, they'll light up a little bit, and then when they get farther away, they'll get dimmer. Right? And what we think is that when the galaxies get close to each other, they're actually causing each other. Why don't you sit in front of Alex? That'd be a good place. Okay? What they think is happening is that there's tidal forces, and the tidal forces are causing them to create starbirths. And we'll talk about why stars are born and why they're not born. But yeah. Here's a whole gallery. They thought that these galactic collisions were like these rare events, but they're not. They are actually really quite common. And they found a lot of them. Right? Here's Andromeda. Andromeda is a spiral galaxy. It's the closest big galaxy to us. It's got a couple elliptical galaxies orbiting it. We've got a couple elliptical galaxies orbiting ourselves. And then this is the Hubble Deep Field. They took the Hubble telescope and they pointed it far, far away from any bright objects. In fact, this is just like a little white dwarf in the Milky Way that just happened to be there. Right? They're pointing it into one of the darkest parts of the sky. Night after night, they took pictures of the same thing, added all those pictures together. Every dot you see here is a galaxy. And we think there's 100 billion galaxies in the part of the universe we can see. And the part we can see is not all that big compared to the whole thing, right? Okay. There are also star clusters. These are in galaxies or between galaxies, right? These are not very small. These are not very big. So there's only maybe thousands of stars in these things. We think that this is material that just got puffed into space and condensed like a little puff of air on a cold day. Okay. And then there's nebula, and I hate the way they classify them. They classify them the way they look, not the way they are, right? So this is called an Emission Nebula. It's called an Emission Nebula because there's super bright stars creating this ultraviolet radiation. The ultraviolet radiation is causing, yeah, he's here. The ultraviolet radiation from these stars is hitting the gases on these things. It's like a black light, right? It's hitting the gases in this nebula and making them glow at a different frequency, right? So here, like the green might be nitrogen and the red might be hydrogen or something like that. These are spectral lines, right? This one might be made of the same stuff as this guy, but because we see the light reflecting off the outside, we call it a reflection nebula. Yeah? And then absorption nebula. Doesn't this guy look suspiciously like the same kind of stuff this guy is? Yeah? Right? Well, this one's called an absorption nebula because it happens to block the light from a background emission nebula. Yeah? Yeah, yeah? I don't like them so far. Here's the only one that's something different. And this one is called a planetary nebula. Has nothing to do with planets. They just named it as a guess, right? Okay. And then the final nebula, I'm not even going to put it up here, is spiral nebula. Do we know what a spiral nebula is? It's an archaic term. What is it referring to? What looks like spirals in the night sky? Like, yeah, if you have a crappy telescope and you look at this galaxy, it looks like a cloud of gas, doesn't it? Right. So all nebulas before they built, I think it was the Wilson telescope up, Mount Wilson Observatory. I don't know what the telescope's called, above Los Angeles. Right. That telescope was powerful enough to realize, and Hubble was one of the people that looked at this. Right. They looked at this, at the Andromeda, and go, oh my God, there's stars in those galaxies. It's not just a cloud of glowing stuff. Right. You can't see the individual stars in that galaxy. The bright stars you see are Milky Way stars that lie between us and the Andromeda galaxy, right? So, yeah, spiral nebula is an archaic term, and people say galaxy now. But before we knew they were galaxies, we called them all spiral nebulas. So, here we are. Nebula, right? Here's that big picture of the Emission Nebula. This thing is what I call a reflection nebula. Doesn't it look like everything like a waterfall? Everything's going this way? Yeah, that's because there's a giant star that's off the screen that is actually its solar radiation is blasting this nebula apart. In fact, it might have been born in that nebula and now it's destroying it, spreading it into space, huh? Yeah? This is the Horsehead Nebula. It's an absorption nebula, right? Yes. It's a seahorse you can see. This is, and we'll talk about how these things form, but this is a planetary nebula. Basically, the short version is that there's a white dwarf in there that's unstable. It's probably got a partner it's orbiting, and it's shooting stuff out of the poles. There are these things called bipolar jets. These things are weird. They have something called point symmetry. So that point corresponds to something there. This point corresponds to something there. This point. So it's like you go straight across from it. It's three-dimensional, so a two-dimensional picture doesn't always pull it out. Right, that's the Cat's Eye Nebula. And this is this nebula. I took this picture and put it on the desktop of our Windows 98 computer, and Shannon made me take it off. She said, Chris, can we take off that eyeball thing? It is sort of creepy, isn't it? If you don't know that it's a planetary nebula. She made me take it off, but you know what? That computer is now my MIDI sequencer in the music room. That picture's back on there. She doesn't care either because she doesn't use it. And then if you zoom out, there's larger scale structures. Another one I really want to talk about because I don't know what. Oh, we got enough time. I'll talk about everything. No, I'm just kidding. There are groups, and groups are like 3 to 6 conspicuous galaxies, and then there's maybe a few other smaller galaxies with them, right? And here's the Milky Way. This is kind of a cute story, right? The Milky Way is actually orbiting Andromeda and vice versa. They're in this little duet, kind of a little doo going around each other, sort of a thing, right? Notice that the Milky Way, our galaxy, has 2 elliptical galaxies, little bitty ones, orbiting us. Okay, you cannot see those unless you go south of the equator. They're all south of the equator things. We can't see them ever. They're never in the sky, not for a few million years or something like that. But these little guys are buzzing around the Milky Way. These little guys are buzzing around the Andromeda galaxy, and then those 2 systems are buzzing around each other. Yeah, and then there's all this, maybe next time we're going to collide. I don't know, maybe, right? Probably not. It's not likely. That it's probably been doing it for a long time, right? This one is the Hickson Compact Group, discovered in 1987. I'm just making this up. I really don't know. Okay. And then there's clusters of galaxies, right? And let me just go to the picture here, right? So there's clusters of galaxies. We're not exactly sure why there are these clusters. There's a lot more structure out there than should be out there, right? We just don't get why there's this structure. We also don't get a lot of other things about cosmology, so there it is. Okay. So putting it all together, solar system, right? You zoom in, here's our solar system, right? The solar system, this map, right, is surrounded by local stars. which are all Milky Way stars, which is in the Milky Way, right?